So this is a practical guide of how we can customize large language models and small language models using supervised fine-tuning for unique tasks. Absolutely. Now we are going to be utilizing a classification task for this supervised fine-tuning, and we will also be uncovering data loading, tokenization, training, evaluation, and of course saving our models, all using our popular libraries, of course. Now let's set up our environment. We will install the necessary libraries such as transformers, dataset, torch, and of course CUDA, and other requires for training and evaluation. Now with this toolkit, we are way much equipped to load models, tokenize text, and run accelerated training loops efficiently. Now we import all our dependencies from pandas and numpy to automodel and tokenizer as well. Now this models lets us process data and fine-tune our models effectively. So with reproducibility in mind, we'll set our random seeds, and also we will be training on the CPU for this example. Well, the result would definitely be the same either we use CPU or GPU. The only difference is that the CPU takes a bit longer. Next, we would load and prepare our data set for this exercise. I will be using the synthetic data that I have prepared for this exercise. This step ensures that the text and labels are split into training, validation, and test data. Now, we are going to be feeding the models that we define in our PyTorch functions, and it will tokenize the text and prepare batches for efficient model training. Now, for this model selection, I will be using LLMs such as the BERT-based and lightweight SLMs such as the DistilBERT and the TinyBERT. Now, this flexibility lets me to experiment with models based on the task, complexity, and of course, the hardware limitations. So each model is initialized with a tokenizer, padding tokens at handles, and the model is moved to the available device, of course. Now, we did set up CUDA, but for this example, we will be using CPU. Now, in order to train both the LLMs and the SLMs on the synthetic data, we will set up our loss function, optimizer, learning rate, and of course, all of the supervised fine-tuning configurations such as the epochs, and all the performance will be logged at each step. So training and validation loops show loss, accuracy, and of course the learning progress. So the best performing model would definitely be saved. And just so you know, the parameters for the LLM is 109,483 and 778. And of course, the small language model is 6,955,010. So once the training is complete, we evaluated both the LLM and the SLM on our test data matrix, such as the accuracy, F1 scores, precision, recall. These all gave insight to how well the model has trained. So in this example, our accuracy was great. The LLM had a validation loss of 0.0096 and a validation accuracy of 1.00. For the SLM, we have the validation loss of 0.0271 and a validation accuracy of 1.00. So lastly, of course, we did save our fine-tuned models and tokenizers. So this can always be reloaded later for inference, or even if we wanted to train them further. And that is how we utilize supervised fine-tuning for LLMs and SLMs. So whether you're building a sentimental analysis or domain-specific assistance or virtual assistants, or just building a specific domain, well, this workflow will help adapt powerful models to your needs. So remember, great models, either you're using an LLMs or an SLM, starts with great idea. Thank you.